John here. Welcome, YouTubers, subscribers, followers, ladies and gentlemen, friends and foes. I'm doing this episode to try to help people out who want to frame their own house or understand the concepts of the skeletal of construction. So that's my intent here, to show you the skeletal of construction. Okay? All right. So follow the, hopefully you can see that, the laser. Okay? Follow the laser. All right, so let's start out with some framing. As a lot of people probably already know, when you frame, the general standard is 16 inches on center. There's 2x4, there's 2x6. Here's 3x6, okay? You zoom in on here and you can see that these are 3x6, all right? And that looks like a 6x8, all right? Because that's obviously holding up. If you look up high, okay, if you take a look right here, it's got a big load, okay, right there. So that is why you're seeing this big post here, okay? Now, let's pan it out. You can see all these are all 3x6. It's calling out for 3x6, okay? All right. If you look down on the ground at the seal plate, you can see the laser. See the laser right here? Zoom in, see the laser? Okay, you can see that's treated. You need to use treated wood, treated lumber, whenever you're touching cement for moisture, all right? So a second floor wouldn't have that if it's on wood, if the flooring is wood, okay? Those are hold downs, all right? Special hardware for seismographic purposes and other reasons to help walls shear off, okay? Let's come over here, the electrical. These are the electrical boxes, obviously. They're supposed to be 12 inches off the ground. They look like they are. Let's see if they are. Okay, they're 12 inches off the ground. And it looks like now they're calling out for 18 inches. That may be the new standard for code. Okay, 18 inches. Plastic boxes. These are plastic boxes. All right, cheapies. I don't really like using them because they twist, and the threads on the plastic, it's just plastic. Okay, that looks like a 12 gauge wire. It's yellow. I'm not 100% sure if it is or not, but it's Romex. You can see how you have to fasten off. 6 inches off the box is good. See that nail plate there? That's a nail plate. Do you see it? Right here. That is a nail plate. The purpose of that nail plate is, you can see if you start to bore a hole close to the edge, you want a plate. So when they drive screws or any kind of a fastener into that portion of the wood, it doesn't penetrate and hit your cables. That would be a bummer. Cause a short, and you're gonna have problems trying to chase it down. You've got your J-bolts, all right? These are the J-bolts. Again, look at the laser. See the J-bolts all over here. The distance depends on the plans. It's determinative on what your engineer decides, the calculations. Okay, that one there is obviously going to need a washer, and believe me, the inspectors will come back and they'll follow that up. Okay, so there you go. Treated wood, hold downs, 3x6. Now this press board here, this OBS actually, it's stranded board is what they call it, OSB, stranded board. You can take a look at it, okay? You see the stranded board? You can see the laser. Okay. This is shear wall, and that's for seismographic purposes. I don't think the entire country calls out for that. It's not on every wall in a house, so you're not going to see it on this wall. You're going to see it in between units. You're not going to see it over here, okay? So what they did is they furred out the wall, all right? Look at the laser beam at the bottom of the floor. You see that? They called out for the first stripping to tie in with the shear wall. Okay, see the laser? See it? Okay. So what you're doing here basically is they're just furring that out. Alright, I kind of find that amusing because it's not treated. But then again, it's not structural either, so that's why it would need to be treated. Okay? So let's move along. Thank you, stay with me. If you come up high, you'll see that what they're using here, and again, you can look at the laser beam. Okay, these are laminated I-beams. Okay, do you folks see that? Those are laminated I-beams. And what they do is they basically are taking the place of using 2x joists. I believe it's a cost saver. That was the intent of these. I think they're kind of cheesy, but again, they meet code and they've been all calculated out. So that's what people are using. That's what engineers are using. And they look like they're probably 2x10s. You can get up there and take a peek at it. All right. 2x12s. The height will depend on your span. So depending on how long of a run, a span you have here, that will determine the height. Okay? Let's go to where the top of the wall meets your ceiling joist. As you can see, it's double plated. Now, if you can see right here in the corner, you see right there in the corner, see that? Let me get in there, zoom in on there a little closer. All right, right there. It doesn't look, you see the cracks there or the gaps? It doesn't look like that top board, that top plate is lapping into this wall. It really should be. You see how it is over here? You see how it's lapping in right here? Okay, that's the way it should be lapping in over there. But it's not. So I'm not sure if that raises a problem or not. I doubt it will. Something as small as that. But then again, I'm not the inspector. So have to wait and see. All right, let's get this up a little bit higher for you folks. All right. So again, we have that. Now you can see this here. These blocks here, these are just hold down blocks for the plumbing. Not a big deal. Okay, zoom it out, pan out. Same thing here, right in the middle there. You can see it, see the laser, okay? Those are backing blocks for the plumbing, the strapping, etc. Down here you have your PEX. This is all that new PEX piping that everybody's going with. You can see it, red, blue, obviously, hot, cold. You can see here, you see the plumbing? See that plumbing right there? That's a Y. That is a Y, W-Y-E. You see the laser light? Let's zoom it in. John, stay with me. Okay. Look at the pipe next to the red tape. Right there. That's a Y. That's coming off for a vent. That's your vent coming up. Okay. Here's your vent right there. Right there. See if I can zoom in a little bit closer. I'll put it right on that blue pipe right there. That's the vent coming off of this stack here. Okay, which is your drain. And there may be other drains, I'm sure, that are going into this drain up above. Okay, which is why you have this vent coming off next to it. Okay, further along, you can see how they've strapped off this PEX pipe. Okay, and this is the way now. This is the way of construction. A lot of PEX, a lot of OSB board. Okay, a lot of plastic. That's why when these things start burning up, boy, does it reek. We had those fires in Ventura and it stunk up the place. Now, they're using galvanized, they're using cast iron. Cast iron is a requirement as opposed to ABS when you have more than a 2-story. And this happens to be a 3 and a 4-story. So that's why you're seeing cast iron instead of ABS for the drains. Okay? So again, let's kind of review some of this. If you look at the very bottom, you've got to use some sort of a treated board. Look down here at the laser. You've got to use treated wood or you're gonna have problems. And then whatever your plans call out for, you frame every 16 inches on center. And you can go, well, some of the spots don't have 16 inches. And part of that is depending on where these hold downs are and your J-bolts. Go down to the J-bolts, look at this orange marking on the cement. Okay, you see that? If these J-bolts are in the way, then a piece of wood may get shifted over, and it's not a big deal. So as long as you have at least 16 inches minimum, you could have more. And obviously somebody's gonna put a plate on over there, they're gonna have to grind up or whatnot. All right, you can see the nail pattern, the nail pattern. Okay, 4 or 5 toenails at an angle. Generally, 3x6s, you're gonna have 3 nails in it at least, okay? All right, stay with me. So this is what it looks like. It's really not too difficult to understand the concept of framing. Now see, you can see here, see how the top plate has been lapped? Okay, let's go into this corner right here. All right, let me show you this, stay with me. You see up top there? Right there. Let me zoom it in. Go up to the top, to the left of the black pipes, right there. See that? See how it's lapped? California joint, there you go. All right, you can stack a few pieces like that. You can just kind of pack it in. You could even put another stud in that corner if you wanted to, or a 2x4. Because what that does is that'll stiffen up this corner here. All right, you wouldn't want just one. You wouldn't want just one 2x4 there. But you could pack all of this in as well if you wanted. If you wanted to get it even stiffer, not a problem. Okay. So this is what you're up against, folks. It's really nothing too difficult. Here, let me show you this too real quick. Again, you see this? See the nailing? That's all predicated on what your plans say. Usually it's something of this nature, every 2 inches, staggered. Okay, you're at 2 inches, 2 inches. All right, you see it here? Right in here, 2 inches, 2 inches, staggered. These guys just come in here and fly in with a gun. All right. We're just flying in there, getting it nailed off in case there's an earthquake. So God can laugh at what we thought was going to be strong enough. Okay, so this is pretty much it on framing. These straps, again, these are just structural straps to kind of tie everything down. Again, whatever the engineer calls out for, he's the most responsible. He's got his wet stamp on the plans for anything structural. He's going to be the one when Johnny Cochran comes after him, i.e. the slip and fall attorneys, you know, the ambulance chasers. Yeah. Yep. They're the ones, the engineers. They have all of the weight on their backs. Okay? Boy, those holes are getting pretty scary right there. All right, nonetheless, it's like they were bored in the wrong spot. You see them, but they're there. Okay. There's some whoopies. But that's not big enough to compromise the integrity of the laminated I-beams. All right. Okay, it's John reporting on how to frame a building, the concepts of framing, some electrical. Okay, you're supposed to have within 12 feet. It could be tighter now. One on every wall. You're seeing it. This is a kitchen. This is a little studio. Not a big place. It's going to go for $2,500. All right. That's a bathroom and the laundry room. And this is John reporting. Okay. From the apartments. Thank you for watching. Thank you. Real quick, again, shear wall, OSB, and those are like A35. Those are angle. A means angle. They're just basically clips that are fastening this shear wall to your laminated I-beams. That should just keep it all locked in. Got some blocking, not a big deal. The more blocks, the better. But at some point, you start losing money. All right, and there you have it. John.